Happy holidays, everyone. I hope you, your family, and loved ones are surrounded by good health, happiness, and fortune. Welcome back to the channel. Well, if you're new, welcome. Let's get started. In today's video, I'm going to talk about ControlNets. This is going to be a tutorial type of video. I'm going to take it slow and explain things throughout. For this video, I'm going to cover SD1.5 and SDXL. If this video does well, then I'm going to follow up by doing another video on SD3, Stable Diffusion 3, and Flux. Those two will require a separate video since there are a lot of models by different developers. Most of the time when people talk about control nets, we think about this where we have some lines which determine whether it's going to be the upper limb or lower limb, and then we use this to determine the final pose of the character in the generation. However, that is not the only use case of ControlNet. In fact, we can use ControlNet for these here where we have an outline of the character or a particular scene, and then we can generate similar type of images. So in this particular case, we have a bird, we have person, we have some kind of dragon. And here's the other use case. This one is the OpenPose. Probably if you click on this video, you may be thinking about this one, but there's also this one where we have a sketch, and then based on that, we can generate new images. And as you can see, it works on characters, but it also works on buildings. Here's another example where we have building, characters, and even like some kind of fairy type. This is another control net. It's called the depth control net, where we are able to determine the depth in an image. So if we want something to be in the foreground, we can use this type of image. If you want something to be in the background, like this one where we have the window in the background, then you can see in all the images we have the window at the back. So we can use this type of control net to control where we want something to be positioned. Now in this video, I will also be talking about the T2I adapter for SDXL. They are essentially the same as control nets, a little bit more efficient. So we'll talk a little bit about this topic as well. Now for this tutorial, I will be using ComfyUI to explain how ControlNet works. But if you're using a different web UI, the knowledge that you will acquire from this video will carry on to any web UI that you will be using. So let's take a look at this simple text to image workflow. Basically, all I'm asking is for a Chinese woman wearing heavy armor, and then this is the final image that I'm generating. Now, right away, it's pretty good for an SD1.5 model, as you can see here. And it's only 512 by 512. But let's make as if I wanted this person to be on the left side instead of in the middle. Let's say maybe I want to use it as a thumbnail. I want it to be on the left side. On the right side, I'm going to have some text. Now, the first thing that you would want to do is to increase the width so that we have a left and a right. But when we do that and keep everything the same, so we have the same positive prop, and I'm on a fixed seed here. So this is the result we get. So basically the composition itself is changed. Now we have something else that was added in the image. Well, we can try to use the positive prompt to try to influence it. In this particular case, I'm saying it's standing on the left, but this does not quite work with SD1.5. As you can see here, we now have two persons in the image. Now, next thing that we can try is to add a load image node. Basically, we're just changing our workflow from a text to image workflow to an image to image workflow. So if you add your image, and then we basically get the same copy, just different detail from it depending on the denoising strength. Now, of course, you can take this picture, put it in Photoshop, and then manually cut out the character, place the character on the left side, and then generate. You would be able to do that. While this works, as you can see from this example here, it takes a lot of time to do this manually. And the main disadvantage is if you want to change something in your prompt, let's say you want to change the armor that the woman is wearing, then you will have to redo all of these steps manually in Photoshop or some other photo editing software. All right, so here's an example. I've just taken the same picture, the same image, And I've just done a very bad Photoshop job here. I've cut out the other person and just fill in with some random colors. And when you pass this over and you do an image to image, this is what you get. So some of you may be thinking that, okay, this is good enough. We have the character on the left side, and then you can continue on trying to refine the final image. This is quite tedious though. I had to copy the image, take it into Photoshop and manually cut out the character. When it comes to ControlNet, this is one of the problems that ControlNet can solve for you. So first we'll need to add ControlNet. So for that, we can double click on any blank space and type in ControlNet. From the ComfyUI core here, you will see we have an apply ControlNet, and then we have a load ControlNet model. Let's add the apply ControlNet and let's focus on it. All right, so on this side here, these are the inputs. On this side, we have the outputs. And we can see that it's going to take a positive, negative. We have the ControlNet image, and then we have VAE. So if you see a circle, and then there is a dot inside, it means that that particular field is optional. So in this case, the VAE here is optional. These two here are conditionings. So we can get them from the positive and negative. This ControlNet is the model. It's the ControlNet model. If we use the T2I adapter, then it's going to be that T2I adapter model. The image field is not exactly a plain image that you're going to load inside the load image node and then pass it over. It's actually a pre-processed image depending on the ControlNet model that you will use. I will explain a little bit more on this topic. Now, what it's going to do is give you a conditioning, a positive and a negative, which we need to pass in to the key sampler. So let's add it to the workflow. I'm going to add it just below the key sampler. The output here will go as input in the key sampler. So if I make a space, I'm going to move all of these here. The ControlNet will go in between our positive prop, negative prop, and then the key sampler like this. So the positive will go here, negative will go here, and then from this side here where we have the positive, it's going to go in positive, negative, in negative. Now for the ControlNet, you can take the ControlNet, drag out and select ControlNet loader. If this is your first time, it's probably going to say null here. That's okay. The image, for now, let's just connect this image to a load image node. And I've added the empty latent back since I'm not using image to image right now. So this image is not good right now. We'll need to have an image that was pre-processed. I'm going to choose this. It's just an example image. We have it in the ComfyUI example page. I'm going to leave a link in the description below if you would like to follow along, but you can also make your own one. It's just a sketch and that's all. So this image here is going here. And now we need to select the correct ControlNet model. Let's make as if we already have the ControlNets. That's all that you need to do. So the ControlNet is simply using an image to control the final generation. And here you can see a little bit how it's affecting it. Now I have the aspect ratio wrong here, so let me change that. And now you can see it trying to constrict this prompt to this image. So it's trying to control the final output based on this image here. Actually, this is not correct right now. We'll need to add something else. But first, let's try to find out where you can get these ControlNet models. Now, I'm not going to talk about the out-of-date ControlNets. So we have this one. This is the original. You can see the size here, almost 6 GB. Then we got another version where the size decreased to 1.45. And finally, we have this one, which are barely 140 megabytes. So I'm not going to talk about these two, but if you want, you can always download them. I'm going to leave all the links in the description below. I don't recommend them, especially this one. It just wastes space on your disk. If you do not have the ComfyUI manager, I have a video on it on how to install it. Make sure you watch that video first. So I'm going to go into manager at the top, model manager, and then here in the search bar here, you just need to type in ControlNet ControlNet, and you will see so many control nets. They are for SD1.5, SDXL. We have even the T2I adapters also here. Let's just change the base here and scroll down until we see SD1.5. And then let's change the type from all to ControlNet. And in here, you will see only the SD1.5. And you can see that we have only these 722 megabytes version available here. Now, the full list will be on HuggingFace page, where you will be able to download even the Control-LoRA rank 128 version, which is even smaller than this. Now, if you're downloading from the ComfyUI manager, all you need to do is to click on the install button, and that is it. So for example, here, I'm going to get this ControlNet v11 scribble. Click on install. You can check the progress in your terminal. You will see downloading down below. Once it's completed, you can go back. I will say to refresh. You can do Control F5 to refresh the web UI, but you will also need to refresh the node definitions, and it should be available in the load ControlNet model. Click on the drop down and you can see here 1.5. And then we have the scribble. So I'm going to select the scribble version, since this image here is just a scribble. Okay, so now you can see if we have the correct model selected in the load ControlNet model, and we have that particular image, it will try to restrict whatever our prompt is to the image here. And in this particular case, it's trying to control the final generation based on this. So we can see these two ears are becoming wings because the prompt is different. So if I were to change this to a chibi anime character, I think this is what this one is. You can see now it's trying to restrict it to this only. When it comes to control nets, they are essentially controllers. They control the final generation based on an image. Let's go back to our beginning example where we wanted the character to be on the left side instead of in the middle or the right. So here's a character I've used as the 1.5 and it generated a random cartoon character. So I'm going to drag this image inside the load image node here. And because this is not in a format that the ControlNet model can understand, we'll need to install a custom node, which will basically do the outlining for us instead of manually drawing it. So let's go back into Manager, Custom Nodes Manager. At the top here, search for ControlNet, and there's this one here, ComfyUI's ControlNet Auxiliary Preprocessors, and this is the one that we need. It's going to give us all the necessary nodes we'll need for generating that pre-processed image that we can pass on to the ControlNet. So click on install. If you already have it, make sure you are updating yours to the latest version, and then restart your ComfyUI. All right, so once restarted, then we'll need to get that outline. So the previous outline I mentioned was called Scribble. Just search for it and you can see from the ControlNet auxiliary here, we have a couple of ones. I'm just going to select the first one for this example, and we'll need to pass our input image. So let me rearrange them to this Scribble line. And then this one is going to give us a preview here. All right, so we have our Scribble. We'll need to pass this over to the ControlNet. And now you can see it's trying to restrict and make the final output the same as this one. Now it's cropped out at the top and at the bottom, and that is because the aspect ratio here is wrong. So if I increase the height of my empty latent image and do another generation, now you can see we have the full character here. Now the problem comes with so many control nets and what they are used for. All right, so I made this workflow so that I can explain what these different categories are. And in case you're wondering, like we have line extractors, we have, let me disable this. We have depth map generators, normal map generators, there is segmentation, we have tile, there's scribble, we have pose, and this is sort of a miscellaneous category. We have things like luminosity, intensity, color in it. And you can get these categories by right-clicking, go into Add Node, and then scroll down until you can see this ControlNet Preprocessors. Go into it and you will see the different categories here. So we have the semantic segmentation here. We have all of the nodes here, line extractors. Again, you can see how many we have. This is the T2I adapter. We'll talk later on. There's the face and poses estimator, normal and depth estimators. There's others. This one is for SAM segmentation and in painting. We have tile here. We have optical flow, recolor, and then we have some nodes, which is going to help you use the tool. This is the one that I am using right now. This all in one preprocessor. And basically, it's a single node that has all the preprocessors in here. So I can go in, let's say I want to use a normal map preprocessor, I can select this. If I want to use a depth map preprocessor, I can do it like this, just in one node instead of selecting individual nodes like this. So normal would be like this. And then if I need this depth anything, I will have to add a second node. That's the advantage of using this all in one. But let's go back to the example here. And as you can see, it's a massive workflow. I've added as many as I can. And when you talk about line extractors, this is what you're going to get. Now, not all of these preprocessors are going to work for your image. This is going to be my input image, and not all of them will work for it. For example, this one here, you can see that the lines are straight. It means that if I had a building architecture as my input image, it would be able to extract those edges well with this preprocessor. But if I have any character and let's say I want to have just the outline, then I'm going to scroll through the list until I can get something like this, maybe that does not have a lot of detail. For example, there's one here that has a lot of detail, like this one, the Pyra Canny. You can see how much detail it's extracting from the image compared to this one. So if you want the final generation to have more variety and be able to deviate a little bit from that input image, then you want something like this. But if you want it to be as close as possible, then you want something like this. So this is line extractors. And as you can see, it's just detecting the edges and it's drawing that edge there. Now, if we move on to the depth map generator, these are basically going to generate a 3D-like image from a 2D input image. So as you can see, we have a 2D input image here. This is our preprocessed image, and it's going to generate a 3D-like final generation based on this input image. And anything that is white or close to that pure white will be in the foreground. Anything that is close to black will be in the background. And you can basically just select whichever one works best for your image and then pass it over to the depth control net. Then we have normal map, and these are going to convert images to a normal map for 3D rendering or even lighting effects. And as you can see, we have that 3D-ish map that is being generated, and it's going to be used to generate that 3D like image. Then we have segmentation. Is going to try to isolate different parts of the image. In this particular case, you can see that it's isolating the character, but if you have anything that like this, it can even identify where we have the torso, the upper arm, lower arm, the face, and so on. All right, so if we move on a little bit, we have the scribble. I've already shown it to you. There is the pose detection. This one should be familiar if you've seen any other ControlNet models, going to extract the pose of the character. In this particular case, for the second one here, you can see that it's blank, and that is because this is an animal pose preprocessor, and if the input image does not have animal in it, it's not going to detect anything. So you can see black images when running this workflow. It just means that the input image is not compatible with that preprocessor. And everything has a name. You will see like any output image there, they have a name at the top. So this name is going to tell you which preprocessor I'm using to get this output. Now, right now I have only a single person in this input image. That is why I have just one person. But if you have an input image with multiple person, it's going to extract the pose of those multiple person. And you need to pay attention that these two are not the same. As you can see, this one has less detail compared to this one. And you can see in the hands here, we also have a little bit at the bottom. And in this particular one, it is missing. So depending on how much flexibility you want the final model to generate that final image, then you can choose whichever preprocessor that you want to. Now, these are the miscellaneous categories. So you can see like color, it's going to try to use the color to generate an image. This one is based on intensity. This one actually on intensity, and this one on luminance. Okay, like I mentioned, you can get all of these, and you can also determine which control net you'll need by going into add node, then go into ControlNet preprocessors, and then just find the category from there. If you double click and you type in Canny, you will see that we have three different preprocessors. One is included in the ComfyUI core, so that is built in, no need to install any custom node. But the other two are from the auxiliary preprocessors custom nodes, and they are pretty much the same. They will do the same thing. It's just the level of detail that you're going to get from each one will be different. So the first one is from the built-in. As you can see, it doesn't have a lot of detail. It's not that well defined. The second one is the Canny Edge. And then the third one is the Pyrac Canny that we have. And you can see that we have increased level of detail as we go through. Now, the model that you will need to use when you have a Canny Edge detection is the ControlNet Canny model. So let's go back to this workflow here. So let's say we want to use the Canny Edge detection method to try to get an outline of this character, but then have a different person. Maybe we can try to do a woman or a robot. So in this case, the Canny Edge detection is better suited for it, since it's going to have only the outline. It's not going to have the color or the depth or anything like that. So for our image, we'll need to pass it over through a Canny preprocessor. So let's remove the scribble line. From image, drag out, click on search and search for Canny. I'm going to choose the first one, the built-in one, and then let's look at a preview. So let me disable this one, and you can see it here. Now, from the look of it, based on all the lines, the amount of detail that we have here, it's going to keep the hairstyle. We'll have maybe the same position where the eyes are. We'll probably have a t-shirt and the same clothes. We'll also have shoes at the bottom. Maybe the hands will be in the same position. So let's take this image, and we'll need to pass it over to apply ControlNet as the image, and we'll need to change the load ControlNet model from the scribble one to the Canny one. Now, again, if you don't have it, back into manager, model manager, and then just do ControlNet, change the base to SD1.5, type will be ControlNet, and then just look for the Canny from the list here. So this is the 1.1 Canny one. It doesn't say install for me here because I've downloaded mine from HuggingFace page directly. So I went to this page here, scroll down until we can see Canny, and I've downloaded this one. If you're downloading from the HuggingFace page, then you will need to go into your ComfyUI Windows Portable. If you have that one, ComfyUI folder, go into models, go inside the ControlNet folder, and then paste all of your ControlNet files in here. You will also need to paste any T2I adapter models in here as well. Okay, so back to our example here. Let's change the prompt. Let's do a simple one, anime male character, and it's going to use this one. Let's enable our node. Let me change the seed so that we have some random characters, and now you can see we have exactly the same person here. It's a same hairstyle, clothes, and it's just anime. Let's do another one, and you can see keeps on going. Now I have my denoising strength at 0.7. that was from a previous workflow. Let me change it to 1, and the image would be clearer now. So as you can see, if I keep on going, we basically have the character in the same position, same hairstyle, just variation now. All right, so I hope you get the point. Let's go back into the ControlNet, apply ControlNet. Now we are going to look at this strength, the start person, and then the end person. So the strength, if I put it at 0.5, it's basically going to affect it only 50%. Now you can see we have a different hairstyle compared to this one. So let me change Q prompt again, and you can see the hairstyle is changing. We have some more elements now being added. So we have a cape, as you can see. If I go even lower than this, so let's do 0.25. Now you'll start to see more elements that would be changing. Now you can see we have quite a bit of a change. This one, basically the pose itself is not maintained. All right, so this is how much of this input image you wanted to influence the final image. So let's do 1.0. The start percent is when do you want the ControlNet to apply. Right now we have 20 steps. So when we have it at 0%, it means that from 0% all the way to 100, so from step 1 all the way to step 20, it will apply the ControlNet. And the way the ControlNet works is this ControlNet model will run every iteration of your generation. And later on, I will show you the T2I models, the T2I Adapter Models. They are more efficient. They will do the same thing, but they only run once. For now, let's talk about the ControlNet. So every iteration, this ControlNet model will apply, and since we have it from 0 to 1, that's basically 0% to 100%. In steps count, it's from step 1 all the way to step 20. We are going to have that ControlNet being applied. So let's change it from, let's actually change the end percent from 1 to 0.5. That's going to be 50%. And if I click on Q now, basically from step 1 until step 10, the ControlNet will apply, and then from 11 until step 20, it's going to do whatever it wants. So the model will have a little bit more freedom there. And as you can see, even though the strength is at 100% or at 1 here, the final image, the hair, is changing. We have the hand doing its thing. It's SD1.5, and you can see we have variation here, and that is because only 50% of the way that ControlNet is being applied. Now we can do it the other way as well. We can apply the ControlNet is starting 50%. So from step 1 until step 10, we don't have any ControlNet, and then starting the 11th step until step 20, that is when ControlNet will apply, will kick in, and it will try to get that image there. So let's click on Q prompt here. And because the model had the freedom at the beginning, it started generating an image at the beginning, and this is the image that it was generating. Starting at 50%, it tried to change that image to match this input image. So you can see something happening here, and there's like an outline, a shadow, and hopefully it's visible here. So it was trying to change this original image to match this one, but unfortunately this one was already defined at the time. Like 10 steps probably is more than enough for it. And you can see here, if I bypass the ControlNet, this is the image I get with only 10 steps. So let me do that once again. The seed is fixed. So as you can see here, if I add the ControlNet, and it's starting at 50%, so it's going to start at step 11. If I have 20 steps, now you can see it tried to change that original image into something like this, but it could not do it. the image was already formed. So whenever you use the start percent, you want to go really low, something like maybe 0.1 in this particular case will work, sort of. So you will have to play around until you find something. Now, usually you want to use this start percent when you want the base model to start generating something and then try to change it into this. Most of the time you would use the end percent, since the reason to use ControlNet would be to get something that is similar to an input image. We are using an image to control the final generation. So it will be something like start with 0, maybe we'll go to 0.7, and let's decrease the strength to 0.7 as well, just to have a little bit of variation. And then you get something like this. Now, of course, we can change our prompt. So let's do a robot. Maybe we have the seed as fixed, and now you can see we have this cool looking robot here. We're still trying to follow this because our ControlNet has this double line here that generated this, and we ended up with these dotted lines. I'm guessing that's why we have these dotted lines. Now, this Canny here is part of the line extractor category. So if I go back to HuggingFace page here, and actually it's not quite visible here. Okay, so if you right click, you go into add node, ControlNet preprocessors, then you will see a line extractor. And then if you go into it, you will be able to see all of the preprocessors, which is going to give you an outline of your input image. So we have so many to choose from, and all of these will go into a Canny model. So depending on the ControlNet that you have here, you will add that preprocessor here. For example, we can do this line art anime 1 and compare the results. So okay, so I have the Canny here, I have this anime line art here, and this one you can see it has a continuous line instead of getting these double lines, and that's because of that threshold I mentioned at the beginning. It's trying to determine what exactly is a border. So when we are transitioning from one color to another, that is when it's trying to find that edge, and that's why it's called the edge detection method. Now, I'm going to pass this image here over to the ControlNet, and I have the seed as fixed. Let's see how this image will change. Okay, now because I'm using this as the input image, you can see now the robot is more defined. So some of these will give you better result than the other. You'll just need to try them out and see which one works for your particular image. All right, so all of these are going to be the same. Let's talk about the other category, the depth category. So I'm going to add a depth anything in here. And because we are using the preprocessor as depth, we'll have to change the ControlNet model to the Control SD1.5 depth version. So let's pass our image to this preprocessor node. And then let's see the output. And if you look at your terminal, it might even download, this particular node will download the depth anything model automatically. And this one, as you can see, it's trying to determine the 3D depth in an image. So in this particular case, when we pass this and use the depth model, so now you can see our robot now have a little bit more shape. It has a 3D shape, so we can see the shape of it. We know that it's in the foreground because the robot itself is like white. So let me show you with this type of image. So if you have something like this where you can clearly see that the nose is in front compared to like the cheeks and then the ears here, the depth model is actually good for these type of images since we have that z-axis. So I'm going to say a close-up portrait of a woman, and now you can see that we are having the same close-up portrait shot, and we can keep on generating here to get different results. So let me change the seed. Here's another one, again the same thing because it's being influenced by this depth model. So right, so you get the point here. Now we have different types that pretty much like the line extractor. We had the AnyLine all the way to this TED preprocessor. For the depth one, we have the depth anything all the way to Zoe depth map. different ones will work for different scenarios. Some of these will only work if you have some kind of landscape type of images, and usually you want to stick with the depth anything. You can also use the Zoe depth one. It doesn't show here, but it actually downloaded the model, this one here. So it will download the model depending on the preprocessor that you'll be using. Okay, and just need to make sure that you have this depth control net in there. Now let's talk about the other one where we have pose, and we'll need to use this OpenPose custom node. It's again from the same pack, the ControlNet auxiliary custom node pack. And once you pass it, you will get this. These blue ones will be the hands. We have the arms, upper arm. We have the body, the legs. And in this particular one, we also have the face. And of course, we can enable, disable whichever one we want. So let's say we don't want the face. You can disable it, generate again, and it's not going to show the face now. Similarly, if we don't want to see hand, maybe let's say the body, but we want only the face to be in that position, then you can enable just the face and leave everything else as disabled. So let me leave this as is, and let's do portrait of a woman, enable the node, and let's queue it. So right now I just have the face. So what's going to happen right now is it's going to use this to determine the position of the face. So if I were to take this here and hopefully put it like this, so you can see we have the face here. If I move it, it's approximately in that particular area, right? So it's using that position, generate the face there, and then determine where the rest of the body will be. So I'm on randomize here, and if we go a little bit more, you see that the face will still be here, everything else will change, and you can see it here. So this one determines where the character will be, and that's basically what you would see most of the time when you watch a video on ControlNet. They mainly talk about this one. Let me enable everything. This is going to give you the maximum control when you enable the body and the hands. Now the character will always be here. You can have two of these. So let's say I want to have two people in one image, but I have only one person here. So what I can do is I can do something like this, where I take this image, I expand it by 512. I know that this image is a 512 by 512 image. So if I extend the right side by 512, I'm basically getting a duplicate of this. So I'll get this here. The image is just extended. And then I just bring this one over to this side here, where I'm doing just a composite, where I'm copying this one and placing it on the other side. And then I get this here. So I have the same image, two sides. You can of course do this in Photoshop if you don't want to do it inside of ComfyUI, but you can automate the process basically. Now, once I have this final image here, this image that is extended, I can pass this over to the OpenPose. Let's make sure my width is the correct size now. So that's 512 plus 512. That's going to be 1024. And pay attention to what happens to this pose preview image. I will now have two person in my image. So I can take this image and pass it over to the apply control net, change the model to OpenPose, and let's click on Q. And here you go. You can see what's happening. So now we are getting like similar person here. That's because of the SD1.5 image. It's not really great to do these higher resolution, but if you have two person in your pre-processed image, input image, then in the final generation you're going to have two person. So this OpenPose is very powerful when you want to control the number of people in your generated image. So if I use a standard text to image, I say the same prompt, portrait of two women standing. It's very difficult for me to get these two to be at the correct distance from each other, or if I want them to have like one arm on top of the other one shoulder, then it's very difficult to do it with just standard text to image. But if you have an input image well, in this case, I've just constructed the input image, but if you have an input image where we have two friends, the hands are on top of each other's shoulder, then you can use this to get these points. Then when you pass it over to the OpenPose ControlNet, it will take those points and then based on that generate this final image. So if I drag this and make it sort of the same size here, you can see that it's actually going on top of the other one. Or maybe I can do it like this. So let me decrease the size here. Now you can see perfectly what is happening. So wherever we have those points for the eyes, this is the image that was generated, and these are the points that we have. So you can see the eyes, the eyebrows, nose, the shape of the chin here. We have the body as well, right? Where the arms were. So from here until the elbow, we have the wrist here, the fingers. There's actually like an OpenPose that can actually do hands, and you can sort of see it here in this one where it's trying to do for each one. And since we had two of these, we actually get two in the same position here. Now let's see if we have anything else. This video is going too long. I underestimated how long it's going to take. Might have to do another video for T2I, but let's just see. And you can mix and match. So I did not cover this one. Let's go back here. So let me do the original one. Okay, so let's say I want to combine the Canny with depth. Let's go back to that cartoon one. I'm going to add the Canny once again. Let's do a preview. Let's pass it over to apply ControlNet and let's queue prompt. Okay, I'm going to change this resolution here to 512. All right, so this is the Canny. We've already seen it, but let's say we want to combine it with the depth one, since we want to have a little bit of 3D-ish type of effect. So to combine it, we just need to keep in mind that the ControlNet needs to go in between this K-sampler and whatever positive and negative. In this particular case, since the positive and negative is already going inside this ControlNet, the second ControlNet that we'll need to apply will come right after it. So we can copy this. Positive goes here, negative goes here. We'll need a new ControlNet model and then select the depth from the list, pass that over. Now I'm going to use the same image. Let's just do depth anything and simply connect it. So this image will go into the second ControlNet. So we have first ControlNet here, second ControlNet here. When you have these two, you may want to play around with the strength. So I'm going to go with 0.7 on both, and let's give this one a go. So now you can see it's going from the first one into the second one, and then generate the image there. Now since we have two, it will have more constraint over the final image. So in this particular one, you can see that the position and of the overall character will not change a lot, since it's going to determine this detail that we have here based on this image as well as this image, right? So now we have more control over the final image. So you can see we have pretty much the same every single time. Like the face is changing, colors as well, but it's the same thing every time, and the accessories, they are pretty much the same. Now if I were to use like the different Canny one, so if I were to use that Canny edge, will even add even more detail to it. By the way, you don't need to use the same image here. So I can do something like this, where the first one is this one, the second one is this. Now I have sort of a combination between the two now. But whenever you have these type of cases, you'll need to make sure that one of them is not overpowering the other one. So you may want to decrease the strength of one over the other. And here's an example. I think this one is a better example in showing how to use two ControlNets and why you should use two ControlNets. So in this particular example, I'm extracting the pose in the first ControlNet. So I'm using the OpenPose preprocessor and the OpenPose ControlNet model. And then for the second one, I'm just doing a background. So some kind of festival that's happening in here, and I'm using the depth anything preprocessor with the depth control net. When you combine both of them, as you can see, I have the pose for the character, plus I also have the background. So I have some kind of triangle here. You can see that we see that triangle here, an arc, like a semi-arc, and then we have it here, plus we have these buildings in the background. For SDXL, the only thing that will change is this load ControlNet model. You just need to make sure that the ControlNet model is for SDXL. So for that, you will go into the manager, model manager, and then the type here, change it to ControlNet. The base, change it to SDXL. You can also search for ControlNet here, just to filter down the list, and you have so many choices. So pick any one that you would like to use. Make sure that if you're using a preprocessor that's Canny, then you download the Canny version for SDXL. If you're using the depth one, then you download the depth version. It's basically the same thing as SD1.5. Now, of course, the other thing that you'll need to make sure is that you have a base checkpoint that is SDXL. In my case, I'm using the Juggernaut XL. Of course, your latent image will also need to change depending on whether you are using SD1.5 or SDXL. Now, there's one more thing that you can change, and that is the resolution here. Right now, I have the resolution as 512. So let me fix my seed here, and let me generate again. As you can see, with a resolution of 512 in my preprocessor, it's pretty good. We have some good detail, and let me try to capture it. I'm going to click on the Q prompt. After changing this, I'm going to change this to 768, and that is the shortest side that I have here. The resolution here is not determined by the longest side, it's instead by the shortest side. So if you're doing 768 by 512, then this resolution is going to be 512. The preprocessor will automatically calculate the longest side for you. So let me zoom in here and let's Q prompt. Now, hopefully you've seen that it's a little bit cleaner now. Maybe I can try to capture this by opening it. So this is the clean version, and if I go 512, I should get a second one here. Okay, so this is the 512 and this is the 768, and hopefully you can see that there's a difference. The image itself is bigger, that's one, but it's also cleaner in the 768 version. So make sure that your resolution in the preprocessor, if you're using the individual preprocessors, they also have this resolution. So let's do Canny Edge. As you can see here, this Canny Edge has a resolution here. So make sure that you're changing the resolution to match your empty latent image, just so that you have maximum quality when generating it. Of course, SDXL models are usually better in pretty much most scenarios in generating the images. So as you can see, this cartoon character is much better in the SDXL format versus when I was doing it in the SD1.5 format. Okay, so quickly, let me go into the manager, model manager here, and SD1.5, this one will be T2I. So as you can see, we have the same thing here, depth, segment, this SEG is segmentation, and we have a sketch. This one would be for the scribble, key pose, OpenPose, we have the color and the Canny. Using the T2I adapter is exactly the same thing as SD1.5 or SDXL ControlNets. Basically, you just need to make sure that your base checkpoint is matching your T2I adapter. In my case here, I have an SD1.5 T2I adapter. It's the sketch version, and I have an SD1.5 checkpoint. I'm also just using the same input image. I have my resolution here set to 512 by 768. So my preprocessor is at 512. And since this is a sketch ControlNet, actually it's a T2I adapter model, I am using a line out preprocessor. So this is the line out that I'm getting. And then the final generation here, as you can see, we get the same person, pretty much exactly the same thing as ControlNet. Some of you may see a speed up when using the T2I adapter. And I can click on generate. It's exactly the same thing. You will still see that the person or character will still be like the reference image here. Everything else will change, like background, the clothes, color, everything else changes, but the character is still the same thing. And by the way, the ControlNet is actually used in some online application. So for example, if I were to draw some kind of tree here, and you may have seen in some application where you draw something and you give it a couple of seconds, you get an image of your drawing. So that's one application of ControlNet. Right now, I'm having to do it manually. So I have to draw something and save the image and go back into ComfyUI, open that image, change the prompt, and then you get an image based on your drawing, right? So you get something like this and keep on going. So if you've seen that, you've used some of these applications, that's basically how they are doing it. In the back end, there's some ControlNet that's happening. They probably have an image to text model as well. So in this particular case, I have this Florence. It's from a Microsoft model. And so what's happening right now is the person will use some kind of front end to draw in here. That drawing will go through a model that will add a captioning. The captioning will go into as positive prompt, and they will also do some kind of a scribble, or I think it's going to be better to add the scribble line since it's just a drawing, and then change the model to scribble. I'm guessing it's black and white because, yeah, the image to text model, the Florence one, is saying a black and white drawing of a tree. As you can see, every time a black and white drawing of a tree here. And that's why I'm getting this black and white of a tree. But if I go back here, and this is going to do this really quickly here. Well, I'm not even sure if this will be recognized as a tree, but basically that's how those online applications are doing it. So if you're paying for those applications, you may want to do it yourself. It's very easy to do it inside of ComfyUI. You can also do the same thing in Stable Diffusion Forge. Let's see the prompt. Okay, this time it says a green mushroom cloud on a white background. And yeah, so that's how you get those unexpected results, since depends on what this Florence to run model. But in those online application, I'm not sure what they are using. Basically the same thing. It works exactly the same way. Some of you, if you have lower VRAM, you may see a speed up when using the T2I, but it works exactly the same way as ControlNets. I think this video is a little bit too long. Like I mentioned, if it does well, if it's well received, and you guys would like to see more ComfyUI tutorial, then I'm going to make a follow-up video talking about SD3 and Flux. I'm not sure if I'm going to split the video. It depends on how long the tutorial will go. So that was an introduction on the ControlNet. By the way, ControlNet is going to give you a positive and a negative output. That's it. As long as you understand that you will only get a positive and negative output out of it, you can integrate ControlNet in any workflow that has a positive and a negative input field. All right, so quick introduction on SD1.5 and SDXL ControlNet. Let me know what you guys think. If I've missed anything, there's a lot of ControlNets to talk about. If I've missed anything important, let me know. I can cover it in another video. If you don't really like this type of videos, just give it a dislike, and that will let me know that I should not be making these type of videos in the future. So thank you for watching until the very end. Have a great day. Happy holidays. Take care. And I will see you next time.